Hello everyone, good afternoon, good morning, good evening. Not sure where you are in the world because I've seen registrants from all over the world log into the webinar. So thank you very much for joining us. I'm really excited to be able to pass on to you Collin Coker from Viking Cold Solutions. So Collin's going to discuss a little bit around some of the emerging technologies that they're seeing as a business, which are complementing solar energy. Collin has 3 decades of sales and leadership experience in B2B and B2C sales and more than 20 years in the energy industry. He brings a broad experience across both wholesale and retail energy and has a consistent record of building and leading successful sales organizations. He served as Senior Vice President of Sales and Marketing for Startex Power. He's been Vice President of Sales for Gexa Energy, Director of Sales for Direct Energy, and his wholesale experience began in the California market, one of the hottest in the US, literally and figuratively. He was directing Reliant Energy's mid-market wholesale origination efforts there. He attended Texas State University and has sales and leadership certifications from universities, including Wharton School of Business, Villanova University, Rice University, and Motorola University. So, Collin, I'm going to hand over the audio to you, and you will be able to take the microphone.
Thank you for the introduction. Yes, thank you for the introduction, Joanne. I'd like to invite everyone, good morning, good afternoon, good evening, depending on where you are in the world. And thank you for making time to attend the webinar today. We're excited to share with you different emerging technologies that are associated with solar energy storage. We've got good experience that we've learned in our particular area, and we'll dive in a little bit deeper as we go throughout the day today. So please don't hesitate to pose questions online. Joanne will help us manage those questions, and I'll look forward to sharing with you the information today. First of all, just a little reminder of where we are with the growth of solar. It's been an accepted technology for many years. We're seeing exponential growth year over year. There are a few points in this particular slide that most everyone, I'm sure, is familiar with, but we'd like to point out in particular with regards to considering these emerging technologies that have an impact and will help exponentially the growth of solar. So in this area, we did see that the trend overall continues to go upwards. We saw a little bit of a blip in from 16 to 17, and many factors there that changed the economies of solar implementation and the economics associated with that. But the one thing that we'd like to point out is from basically 2012 through 2013, we'll talk a little bit more about it, is basically how pairing solar with different emerging technologies, in particular storage, will continue to help the growth of solar overall. If I move to the next slide, we'll talk about a little bit more detail on the variable types of solar and renewable energy, solar being most prevalent as far as the growth in each of these years, 2005 through the 2022 timeframe, these 3 bars that we look at, you see that obviously solar is the largest growth percentage. Now the salmon colored portion at the top is an accelerated case that contemplates some of the governmental barriers that exist today that are lowered or cease to exist, and that will help solar grow exponentially in this forecasted period of 17 through 22. Again, I'd like to make the comment that the creation of some of these technologies and the greater market adoption of some of these storage technologies in particular help us achieve much of that growth and help us achieve eliminating many of the barriers that would allow us to accelerate that percentage in this particular case. Let's talk about some of the storage technologies and drill down a little bit further. So batteries, accepted technology. Some of the examples of different types of batteries range from flow batteries, lithium-ion batteries, lead acid, salt water, different types of batteries. Molten salt, from a thermal perspective, is an accepted technology, compressed air. And what we're going to talk about today specifically is the thermal energy storage. and how that basically, in more detail, that we'll talk about how it relates to low temperature cold storage industry and how this technology can make a big impact, and to enlighten the audience on this community of opportunities that exist but aren't very well known. So let's talk about a worldwide stage here. These are some statistics that are quite profound. So 21 billion cubic feet of refrigerated space. This particular load or type of customer in the commercial market is the highest demand per cubic foot of any industrial category. So what we see here in the US is the load that utilities try to focus on, and where the development comes from is load that is the low-hanging fruit has pretty much been identified and is in the mix of the sales focus today. But what we're talking about is a load that has traditionally not been accessible by utilities because the need for 24/7 operation of the refrigeration of these particular facilities. Therefore, they haven't had a lot beyond minimal controls technology to help them manage usage. They have to run all the time, and unless they have some device that enables them to manage that runtime more effectively, or store energy to help them manage that, such as pairing with solar. This category is basically what I would consider to be a sleeper category. Third highest consumption of any industrial category. So not only on a per cubic foot basis is it the highest demand per cubic foot, but if you look at utility ranking as far as the consumption categories, this category is the third highest consumption of any industrial category as well. And in the final point, in the US alone, we recognize over $30 billion USD of electricity that's annually used here. So, the aha moment here, when we look at a global-wide perspective, we've got the potential for roughly 262,000 megawatts of opportunity for solar implementation, installation, and pairing with storage. And again, this is just the cold storage industry we're talking about, and why this technology is so important to the market. So let's drill in a little bit deeper on the type of applications that we're referring to in this global opportunity. So $175 billion of infrastructure worldwide. What we mean by that is this is not contemplated buildings that are on the drawing board. This is infrastructure for dollars invested, development projects that have been completed, where those buildings exist and the rooftop space is open for business. If we break that down into a commercial and industrial view specific to cold storage warehouses, for example, we recognize that there's roughly 11,000 of these facilities. And to give you an idea of the scale, we'll talk a little bit more detail about the individual facilities that we have experience with. But in addition to that, grocery and restaurant. So may not have been a primary target for solar development, but as that market grows, when you pair the ability to store the solar energy in these applications, growth becomes exponential. So here's what a typical cold storage facility looks like. In many cases, even we're in the industry, our first few years in going to the different sites and recognizing that building, well, I never knew that was a cold storage facility. I always saw many trucks and lots of transportation in and out of the facility, but they tend to be off the beaten path. They're very large. They store millions of pounds of food and move millions of pounds of food in and out every day, whether it's simply as a holding place, if it's storage for longer term capacity, or if it's en route from across the country or across the pond. This gives you some scale of an idea of what the usage is. So for example, on an average size, we see anywhere from about 3 to 8 megawatts per day. Now that is an astounding number if you compare that to traditional battery storage. Some of the battery storage technologies and companies that we have seen, their sweet spot tends to be somewhere between a half a megawatt to about 2 megawatts. And they have the ability to reduce a lot of load, but for a very short and limited period of time, maybe 2 to 3 hours at the max. This technology in this vertical that we're talking about today has the capacity to reduce 3 to 8 megawatts hours per day. So that could be half of the load for over 10 hours, or that could be the whole load for 6 hours. So on a square foot basis or on a square meter basis, this also gives you some degree of understanding of what type of average facility size that we're talking about. So let's talk about the thermal energy storage itself. If you haven't had a chance to look at our website or see any pictures or understand more about what the product looks like and how it works, we store energy in the form of cold. The energy is stored and released when it's most advantageous to run, depending on what we're trying to solve for and what type of solar integration and what market conditions may exist. And then the thermal energy storage that we refer to as TES. This product addresses some of the challenges that we've traditionally seen in the solar market, such as intermittency. We optimize the economics of the overall value proposition to the customer, so the investment of the solar itself makes much more sense, and the storage element helps make those economics and the customer payback scenarios look much more promising. And then it improves the refrigeration efficiency. And what we mean by that is having this storage vessel or this heat sink in the room that traditionally has run 24/7, now that we're running on targeted times and we're shutting down the refrigeration during periods of time, we actually increase the refrigeration efficiency by that time that we run. If we run more compressor hours, for example, in the evenings and mornings when it's most advantageous to run, where the compressor is designed to run at its optimal efficiency with lower condensing temperatures. So there's a great deal of efficiency that goes along with the technology in addition to other value propositions. So our experience tells us that the cold storage industry has been late to adopt in solar also. The average age that's been published by industry experts is about 53 years old in this industry. They have a difficult time recruiting new up and coming youngsters to have the desire to work in a very cold environment. And so there's a lot of folks with an old mentality and a traditional way of running their business. So we've got a lot of opportunities in this particular vertical based on education and the pairing of solar with storage to make a much more optimistic view and accepted financial consideration. So let's talk about just the key components of our system. We like to think about this as an elegantly simple system. We have 3 key components. We showed you a brief picture of what the cell modules look like on top of the racking system in the freezer in the previous slide. So you have the cells that are individually sealed. They're filled with a phase change solution, a combination of different types of water and salts that are designed to specifically operate at a given temperature in the freezer. We have intelligent controls that help tell the refrigeration system when to run based on what we're trying to solve for. And then we have a cloud-based monitoring and reporting portal that monitors the facility and the operations 24/7. The fundamentals, again, if you look at the bottom left of the slide, you'll see a picture. This is a real-world example of a very large warehouse. This one is very close to our example that we've given, about 100,000 square feet or 10,000 square meters. The cells are mounted at the top of the racking system up high, where natural convection occurs, and we are able to absorb the heat into the cells very effectively. We use the airflow from the evaporator fans to blow across the cells to extract the heat and refreeze the cells. So there's nothing mechanical that changes within the freezer or the operations itself with regards to the mechanical system. So we're able to integrate with any type of refrigeration system, controls, racking, etc. Our system is passive. We have no parasitic energy loss. So for example, as a storage vessel, as a thermal battery, if you will, we don't have any losses when we go through a charge state, and we have no losses when we go through a discharge state. The cells being up high in the room and above the product itself, it constantly rains down the heavier cold area, which provides a thermal blanket around the food. So we stabilize the food temperature because we're absorbing the heat in and out of the cells much more effectively than previously when the heat was absorbed and extracted from the frozen box of insulated food. So we keep the temperature of the food much more stable during operations. Again, we talked about our cloud-based intelligent monitoring for energy efficiency. So we're able to see how the operation's running. If there are any anomalies, we quite frequently recognize that if a fan is not working, a compressor, we see early signs of degradation in performance, and we're able to report that out to the owner-operator. And at the end of the day, we provide a report card to all of our customers every day for every facility, for every room, exactly how we performed the prior day. We provide that via a live portal that the customer can log into and determine where they sit at any given moment for live data, or we provide a PDF post-day report that shows specifically how we performed. And in the case of integration with solar, we're able to show how effectively we've used any excess or been able to perform lessening the load from the grid and better utilizing the solar generation during the day. So in this slide here, this is representative of one of our installations, and the picture is quite compelling here. How we would normally operate a system without solar is that we would reduce the amount of runtime during the day. It would increase the runtime during the evenings, which makes sense. However, in a solar application, we're utilizing that low cost, no cost generation. And in this case, San Diego Gas and Electric, this was a third-party validated field study that was conducted by a California utility, San Diego Gas and Electric. And in this particular study and application, the facility had excess. So they had full panel array on their system. They had, in most cases, excess they were selling back to the utility at pennies on the dollar. And what we're showing here is from 7 through hours 20, that excess we are now using to run the refrigeration to its maximum capacity on the free generation, freezing or charging the cells in the room. And when the sun goes down, the primary objective was to at least keep the compression load off of the grid for a period of about 6 hours to alleviate what California has dubbed as the California duck curve, which when the sun goes down in markets where there's a high proliferation of solar energy, much of that load comes back on the grid very quickly. It's very difficult to manage, and then after a few hours starts to taper off. So during this particular study, that was the hope that we would be able to maintain several hours keeping that load off the grid. What we've been able to effectively do is keep that load off the grid for a 12-hour period. We go from roughly 7 p.m. at night when the sun goes down until 7 a.m. the next morning, dropping from roughly about, in this case, roughly on average from a 40 kW to less than 1 kW for a 12-hour period. In this case, it showed that we reduced our overnight grid dependency, and we reduced the consumption by 95%. And on an annualized basis, the overall savings when calculated on better using and utilizing that excess during the day and reducing or eliminating the usage at night, it represents a 39% annualized refrigeration savings. So lots of detail here, but what I'm trying to paint the picture of to the solar community at large is there is huge opportunity here. This is not only a great value proposition in and of itself, but when paired with solar from a development perspective, it basically paints a very promising landscape. So let's just talk about the benefits that we see. We've talked on a few of these, but the capacity of pairing the two technologies does increase the return on solar. So an investment that may take anywhere from a 5 to 20 year period to satisfy investor expectations on return on investment, when pairing with solar to better utilize whether it's excess or whether it's a portion of the facility and lessen the dependency on the grid power, it makes for a better value proposition. It increases the value of the solar to the cold storage operators as well. And I talked about several examples in earlier slides. It provides access to these larger loads and more facilities that have traditionally had to run 24/7. So now you've got this technology that is a huge enabler and allows you to basically target a very specific vertical and hone your skills and get very good at what you do. Manage demand, address renewable and variability. I talked about the duck curve. I'm not sure to our international community if the duck curve is an accepted term, but that is a difficult problem that we're seeing in markets such as California. Hawaii is another highly proliferated solar market. And I can explain a little bit more detail if any of the audience members would like to ask a question later on. We can talk about that. It's a proven solution for operators to reduce their demand charges in markets that have demand charges in peak pricing. And then basically resiliency and effective grid management. From a utility perspective, utilities love this technology because solar is a good and a bad. The solar is helping them implement and deploy more renewable power on the grid. But when the sun doesn't shine and when the sun goes down, they've still got lots of work to do with regards to managing a stable grid for their consumer base. And the simplest takeaway here is there's thousands of megawatts of storage that we've been able to paint the picture in earlier slides. So therefore, I've been talking quite a bit, but I'd like to open the floor up to the community at large, and let's start gathering a few questions that we can answer. Joanne, can you help us administer this?
Brilliant. Thanks very much, Colin. And we have had some questions already from the audience, so I'll start running through those. If you have questions for Colin, you can add your questions to the question box on your screen. Also, one of the biggest FAQs or frequently asked questions that we have on the webinars is whether or not the slides are available. So Colin has very, very kindly provided those, and you should be able to download them as a handout on the software. Now, obviously, if anything goes wrong and if you can't see how to use that, then just drop an email to marketing@solarmedia.co.uk and we can send you the slides after the webinar. Okay, so I'm going to start going through some of the questions from the audience. First of all, Colin, we have a question from James. So he says, please describe a successful combination of solar and cold storage. And the follow-up to that is how easy and expensive is thermal energy storage?
Okay, very good question. So in the case that we've shown earlier on the slide, I'll stick with this information so it's easy to relate to. The San Diego Food Bank was funded by the local utility as part of a project, and that particular example represented roughly, I think, less than 20 months of simple payback return based on the 39% overall savings calculation. I would say, depending on market, depending on what the tariff structure is, that financial return may vary broadly. But in this case, when the solar, this is a retrofit application, the solar system was already installed. So we came in as a retrofit. We helped them optimize their system. So that's one of the key things I'd like to point out here is that in the solar community, it's our understanding that the developers try to optimally design the system to meet the exact load, so they don't have excess in many cases. But we're basically enabling is you to size up to a maximum percentage of rooftop, and any excess that may apply at that point in time is much more feasibly and economically used with when implemented with solar, with the storage piece of the equation.
Thanks, Collin. And we have a couple of follow-up questions around the kind of cost of the project. So question from Raoul Jane is, how does this technology compare with lithium-ion or flow batteries in terms of cost?
Good question. If you look on a cost per kW of avoided cost, for example, many RFPs that we see in the industry for development of storage technologies, the cost to build generation to offset that demand, increasing demand, can be upwards of, in USD, let's say a minimal of $1,500 to $2,000 per kW. Our technology is closer to the $700 mark per kW for basically the cost to implement. The cost per kilowatt hour is quite astounding. The system lasts over 20 years, or the life of the freezer, requires little to no maintenance at all, and has, as I've mentioned, 3 components. The simple cells that are passive, they just act as the heat sink in the room, the monitoring and web-based cloud portal, and the controls. So when you contemplate over even a 10-year period, the cost per kilowatt hour is less than a penny. It gets down to close to 0.8 cents per kilowatt hour over the life of the system. So if you compare that to a battery, a traditional battery, let's say a lithium-ion battery situation, your cost per kilowatt hour in today's market is somewhere upwards of $400 per kilowatt hour.
Thanks, Collin. And I think that, one of the questions that I had just from listening to the presentation is you mentioned some of the demographics around, some of the people that you're working with, kind of, struggling already to kind of hire younger people and being a little bit more set in their ways. So is that a key kind of element for those guys when they're looking at the cost of their overall energy bill? Are they coming to you guys to save money or to be a little bit more green, or is it a combination for you and for them in terms of their drivers?
I think that's a very fair question. There's a little bit of diversity in that approach. We see more of the international community that has a higher priority on green technologies and reducing carbon footprint. Although we're not too far behind here in the US, it's a big part of the mandate. Many executives have that as performance agreements, performance requirements on their in their part of their mission. But it is across the board. Financials obviously make a big difference when considering investing in a technology for energy efficiency. However, if the initiative is hinged around what can we do to be a better steward of the environment, this thermal technology, this thermal storage technology, and this thermal battery basically is made up of materials that you would commonly find in food itself: water and different types of salts. There are, again, when it comes to the life of this thermal battery, it doesn't last 5 or 10 years, and then you've got a hazardous material that you have to figure out how to dispose of. Basically, the disposal, the HDPE cell is recyclable, and the non-toxic fluid, which is the salt in waters that we'd recommended earlier, is also recyclable, right? So much more friendly to the environment. When it comes down to financials as a primary objective, is if we look at how we compare with solar, they get better. But even standalone on what we've installed today in the US, we now have the attention from the utility market that basically says this helps us better manage our grid and access load that we traditionally have not had access to due to the 24/7 requirements. Now we see that utilities in the US are paying upwards of 40 to 100% of the project cost simply to implement the system. So we're very excited to see the adoption from the utility market. We see that similar thing occurring once there's a greater understanding of how we could potentially impact international markets.
Okay, that makes sense. And kind of sticking around the kind of the kind of experience for customers. I know you guys have worked with the San Diego Food Bank previously. Can you talk a little bit around their experience of the installation?
Certainly. It's actually, it's very well planned and very simple. We work with the customer on site to stage the installation of the cells, for example. We have an integrated approach when installing our controls. So we normally install the controls first. That enables us to take a very detailed baseline of how their current operations are. So we look all the way down at the fan level, the compressor level, all mechanical load that's required to run the refrigeration for a given application. We look at that for a several-week period. We model it against weather data to basically understand how that weather normalization is accounted for within the models. We come to an agreement with the customer looking at historical bills and usage data and what we've taken as a baseline to make sure that the customer is happy with that baseline. Then we initiate the cell install after that. The customer typically would work out, if it's an average size that we reference here, let's say a 2,000 square meter facility, that would require maybe a 2-week installation time frame where the customer would remove the product off of the upper racking the night before. We would come in with our crew the next day, install the cells, then put their food back on the racking. So it's a very, very quick and fluid process, very little disruption to their daily operations. And based on our history so far, we've had very good experience with all of our customers.
Okay, perfect. And we've got a couple of questions around kind of smaller size installations. So firstly, TJ wants to know, is this attractive from a financial standpoint for smaller applications? So for example, for a restaurant. And the other question that we had, again, looking at slightly smaller installations, was what is the kind of lowest size of system that you guys can install?
Yes, we're trying to paint a picture of what the overall opportunity in the market looks like. Restaurants obviously would be much smaller rooftops. The size of the freezer or the low temp operation in the restaurant would be a much smaller size and less kW overall. But it's a big portion of the load of an integrated solution. So for example, if you've got in a restaurant, if you've got automated building automation controls that controls HVAC, lighting, cookers, medium temp and low temp storage, you have an overall broad facility-wide solution. When you implement solar, depending on what the roof structure looks like, if it needs to be mounted adjacent, we are not the experts with regards to that solar. We're trying to paint the picture that there is a market and an opportunity, and the storage piece is an enabler for you now to consider this as something that you may not have previously considered, because it improves the economics with regards to these type of applications.
Perfect, thank you. And we've had a couple of questions from the audience just in terms of the kind of geographic environment that this could operate in. So I'll kind of package them together. Firstly, how far is this technology commercially successful in the MENA or Asian regions? So in particular, India. But also I think a similar question is what's the need that you kind of see in colder environments, where there might be sort of applicable businesses. So that was a question really around India, and then really Northern Europe, I guess, and some of the kind of colder environments that the system could operate in.
Yeah, that's a very fair question. We wondered that when we first started visiting the international community, is we spent a lot of time in the Nordic region. They have very sophisticated systems, very sophisticated buildings and operations, but high degree of interest in what we do because of the fact that their wholesale prices are very volatile. And so depending on what demand looks like on a given day, if in these industrial facilities, they may have the opportunity to go to the wholesale market and do procurement. And if they had some type of technology that helps them ride or float longer periods of time while protecting their food during those high periods, it's a win-win scenario. If you pair that with solar in those regions where the solar is prevalent, now it may not be a California market. If you're in Denmark, I don't know how many hours per year that would differ. But even in cold regions, we've had a high degree of interest based on what we can do because it provides the operator more flexibility. And I think what we're trying to say here is it also enables them to bring solar into the picture because there's a greater value stack.
That makes sense. And in terms of the kind of facilities that you're installing on, do you have a preference for retrofit or new build? Is there any difference in terms of how the technology would apply in those kind of two different building types?
I don't know that we have a preference. I would say that the thing that we have a preference on is the operator itself. If the operator takes good care of their facility, once a maintenance item is identified, if their mechanical equipment is well maintained, that makes for a really good outcome. If we have a facility operator that does not repair equipment and is constantly behind the ball with regards to increasing efficiencies, that affects our ability to perform at the top level. But both new construction and retrofits we have experience with, like solar.
Brilliant, thank you. And a question really around the life cycle of the system. So what's the expected life of thermal energy storage?
We expect the system to last in excess of 20 years, or what is expected to be the life of the freezer. Mm-hmm. So that's where the economics on a cost per kilowatt hour get down to such an astounding level, because not only can we shed very high volume of megawatts, but we can do it for long periods of time. One of the examples I would give, California installation, roughly 10,000 square meters. We go from about 850 kW peak to about 400 peak, and we shed that load for over 10.5 hours, and we do that every day. And we're able to maintain product temps during that period of time. So this is an example of a facility that did not shed to any high degree because they constantly run to maintain temperatures. So that's a good example of going deep and going long with regards to this technology and how it's much different from batteries that does not have that capacity, and the environmental consequence of that.
Yeah, and I feel like often when we talk about storage as an energy industry, what people are really referring to is batteries, where you guys are actually working on a technology that has different advantages and different benefits to end users. And I think it's a really good example of something that can be co-located with renewable generation. So one of the other questions we have is whether you're actually already working currently with any solar developers, and if so, kind of whereabouts are they? Are they broadly in the US, or have you got kind of projects that you're currently working on in other markets?
We've been primarily targeted on development projects so the answer is yes. We're working with several different developers. We're targeting most of our efforts here in the US at this point in time. We're working on retrofits as well as new construction. We're working on facilities that range only from, let's say, 5,000 square feet or very small up to several 100,000 square feet, or tens of thousands of square meters, if you will. So we've got a broad range that we can serve. So I think we would entertain looking at international projects, but we recognize that one of the most important things from an international stage is that we've got to have the right partner that has the capability and skill set to not only execute on the project itself, but take the time to understand our product and be able to support it as well.
That makes sense. So a couple of questions really around just going back to some of the revenue and the cost that you mentioned. So the question from Maribel, who just said, would you mind repeating the cost of the system by kilowatt hours? I think she may have missed that earlier on in the talk.
Yeah, I mean, definitely a big disparity in the numbers. How we calculated the less than a penny per kilowatt hour. So if we're shedding, in the example I gave, if we're shedding 400 kW and we're doing it for 10 hours, right? So you've got 4,000 kilowatt hours of load that we've shed over that period of time. So if we do that every day and we do that over a 10-year period, the ultimate cost per kilowatt hour based on the investment and how you've shed that associated load is how we've calculated the less than penny per kilowatt hour. And that's only on a 10-year period. If we calculate the full 20 years, and we have some facilities that have been operating for over, I think, close to 8 years now in the Puerto Rico market, in the Caribbean. And so we've got a 10-year warranty on our system, but the life cycles of the phase change material and the HDPE material, which is the cell that houses the material, has a 20-plus year expectation. So we believe that the life is expected to be well over 20 years, or the life of the freezer. The economics even improve from that.
Sure. And just a follow-up to that, TJ asks, when you say it's, in terms of the pricing that you mentioned, what kind of size facility is that pricing based on?
The example we've tried to give today or provide today would be somewhere in the 10,000 square meter range is what we see it in the industrial size as an industrial cold storage facility, which is our primary market. Secondary markets of supermarkets and restaurants. Obviously, that is very dependent on what area that you're talking about and what opportunities. Our ability to affect, let's say, a supermarket load would not be as high a percentage compared to an industrial freezer application that's large. But the solution works in either case.
And presumably, there's room for a slight difference depending on, the country you're talking about, the energy prices in that country, and so on and so forth. So you're not giving a kind of a solid gold answer, but this is the best, kind of current picture that you have.
Right. I think in all fairness, when you ask a solar developer, well, how much is it going to cost to install your solar? Their answer is probably going to be whether it depends on a lot. Depends on the rooftop, where you're located, and we're in the same boat. I mean, the facilities all differ. There's different types of refrigeration systems, different types of systems, and there's different requirements that we have to consider from an interface when it comes to the controls also. So it's broad based on the application. Yeah,
that makes sense, and all the kind of normal stuff that we consider, like the off-taker, their creditworthiness, the size of the project, and so on. But I think and one of the other kind of audience members made a good point. Presumably, that cost will improve as you guys grow bigger and do more projects and kind of reach a larger scale.
Correct. So, for example, most of our installations to date have been retrofit. I think it makes the most sense when it's a new construction because there's lots of efficiencies that can be gained while the contractor is building the racking system, for example. They can build it in and install the cells at that point in time. When the control system and engine room is put in, all the wires and control units themselves can be installed at a much more cost-effective labor rate. So it makes the most sense. But being a new technology, we've had to prove ourselves. And that's one thing I'd like to point out, is we've been able to prove our technology in the associated performance from very small applications that may be as small as a small walk-in freezer restaurant, where we provide value, all the way up to these massive industrial facilities we're making. When you pair that with solar, it makes that value proposition that much stronger.
Sure. And I've got a couple of questions really around, how as you guys grow, this will become kind of more common practice. So, firstly, do you see solar plus storage as as part of an integrated building solution? And if so, in what applications?
Yeah, I think so. This part of what the value of today is the education piece. We've got something here in the community at large. We want to help understand how we can, best work together take advantage. But there's a significant amount of education that needs to take place. But absolutely, the answer to that question is yes. This will become, whether it's traditional battery or whether it's other types of storage technologies that we yet know about. Mm-hmm. Storage is basically the panacea that makes the solution work.
Mm-hmm. Mm-hmm. I think in terms of the future, one of the questions we have here is whether or not you see this as the kind of potential future best practice. So when we think about food banks, food recovery programs, be they nationwide or kind of continental worldwide, do you kind of think that this kind of solution is going to become, just best practice in terms of those companies and supply chains, kind of daily kind of operations?
Well, I think so. If you back up a little bit and look at, okay, where's the value to all the stakeholders? And let's name those stakeholders. So the stakeholders are not only the owner operator of the facility. So you mentioned the food bank. Mm-hmm. Their vision, and in particular, I invite our audience to go to the San Diego Food Bank website. They're an outstanding operation, very large operation. They feed millions of people every year. They do a lot of good things, but if you look at what they have done from a planned efficiency initiative where they put skylights in, they implemented solar, they put automation controls in, they manufactured and built a recycling machine for the wasted food that would be turned into mulch to beautify the city. They learned about Viking. The utility helped do an education program. It looked like a good candidate so that we could show what we could do. But overall, that facility now has gained several accolades and recognition milestones. So they're the first food bank that they know of in the world that has achieved gold LEED status. They received what's called the Utility Champion Award after the year that they installed the Viking system for making the biggest impact with a new technology in the facility. So overall, in cold storage, talking about why this makes sense and why it may become mainstream and why companies or entities like the food bank would consider something like this. From all the stakeholders, you have the owner-operator, you have the utility, who now recognize they've got a big challenge in managing the variability in what I've referred to as the duck curve. So they want tools to help them manage that so they can bring on more solar. The more solar that comes on without solutions to those problems becomes problematic. And then you have the developers and the community at large that creates the technologies. So you got growth of emerging technologies and industries that help support all the stakeholders and all the value propositions. So, from our stand, maybe we're a little bit too optimistic and too myopic because we've got something that we believe is great. But when you look at what we've been able to do, and what you look at what the utility has said about pairing these two technologies, and the actions that they're now taking, and the adoption of the customers that are now coming along, you've got a perfect recipe.
That makes sense. Thank you. And we have a question really around the fact that I think it's Russia specific, but the fact that in Russia there are kind of difficulties during winter months of kind of accessing food, and whether or not your solution is kind of something that could play a part in improving food supply chains, in countries where maybe they have less favourable weather patterns or difficult supply chains to actually get food to where it needs to be on time. What are your thoughts around that?
Man, I love this audience. They're asking questions more about how we can impact and change the world. This is great. I don't want to get too far away from our core audience here, but yes, there's a statistics that's broadly published. It's basically touted as from farm to fork. So across that whole that global cold chain where food moves from the field all the way to the tabletop, there is over 40% of the food that is wasted. A big portion of that happens early on in the food chain, but a significant portion occurs from truck to truck, from dock to dock, from building to building. We've even analyzed this from the farm to fork in several occasions where we've seen that food has moved from a refrigerated truck to a refrigerated warehouse to ultimately the grocery store and to the customer's refrigeration. It moves and is in and out between 15 to 20 different facilities. So it has the propensity to heat up and get cold, and all of that breaks down the cell structure of the food itself by virtue of microcrystallization and thawing that occurs. So yes, this technology, not just the building technology, but phase change material and the use of that thermal battery has the capacity to be used all along the food chain.
Super. And someone else is asking around sports and sports stadia. Presumably that would apply there as well.
Say that one more time. Did you say sports?
Yeah, so sports stadiums.
From a HVAC perspective, or from just taking care of the food? If there's a freezer in any, if there's
both.
Phase change material it can be used across a multitude of temperature ranges. What we specialize is in low temperature, so anything below freezing, below 0 C or Fahrenheit, and it target primarily around operations around frozen foods. Phase change material has the capacity to make a big impact in the medium temperatures, let's say the coolers, and also there's technologies today that are used passively in ceiling tiles and walls and buildings to help manage uses as well. We focus specifically on low temp today, and we want to make sure that we are tight and we're well focused on what we can do in the low temp, how we compare with technologies like solar. Let's create some success stories and some market acceptance, and then let's move and grow from there.
Brilliant, thank you. And we are literally down to the last couple of questions. So I've given you a very good grilling this morning. Thank you, Collin. We have a question around kind of how the system functions with cogeneration. And that is literally the question: how does your system function with cogeneration? But you mentioned obviously that you guys provide a kind of a complete system, so it's not just the storage or the PV, but also the software that comes behind that. Can you just run the audience through that a little bit quickly before we go?
Sure. I'm going back one slide for everyone who's still looking at their screen. But this is a good takeaway on the overall benefits of the combination of the two. But if you want to look a little bit more specifically about the system itself, one thing that we didn't spend a lot of time about, but there's a thermal backup protection element. So you've got this heat sink that's up on top of the food, which constantly rains down cold. It also acts as a natural barrier from heat that comes in through the envelope of the building. So there's like this blanket that's over the top of the food. The variability and the flexibility that it offers now, so if it's a market that has no demand charges and only charges cost per kilowatt hour. We experience this in Puerto Rico, for example. We run for optimal kilowatt hour reduction. So we move more of the compressor runtime into lower temperature times of day, where the compressors have the capacity to run at their optimal design efficiency. And during the day, we cycle off or rotate the evaporator fans to simply stir the air and reduce compressor runtime to make sure that we absorb the maximum amount of heat in the cells during the day. With regards to the environmental impact, I think I've touched on that, is that being viewed as a thermal battery, not only to help change the way that operators operate today, but what happens at the end of the life. How does this compare to a traditional battery? Very environmentally friendly. It's a passive technology. It's not parasitic, so I don't use more electricity at the nighttime to create the end result. I actually use less electricity and I'm able to store energy in combination and in tandem.
Super, thank you, Collin. And I've got two very, very quick questions. We have 3 minutes left of the webinar, and the software automatically stops recording after 60 minutes. So we need to get these ones in quickly. The first one is whether you guys do any other solutions. So are you sort of investigating heat storage or anything else? And the last question really was, where can the audience follow you when it comes to social media? So LinkedIn, Twitter, that kind of thing.
Yeah, excellent. Well, first of all, I would like to invite everyone to visit our website. I think we've done a good job on creating different things to read and see. So if you go to our resources tab in particular, or our news tab, you'll see customer testimonials from companies like, let's say we've got a Nestle facility in California, and the frozen gourmet owner-operator there has talks about the installation, how it's made an impact on their facility, how they've been able to be more compliant with their customer requirements and delivering food at a more stable temperature, and then the overall net savings has just been icing on the cake from an energy standpoint. From a social media standpoint, we do have LinkedIn, we're on Twitter and Facebook and Vimeo. So we'd be happy to make all of those resources available to everyone. We probably attend close to 20 to 30 trade shows and events across the globe, most of which are here in the US, but we do attend the Global Cold Chain Alliance annually. That was recently held, I believe, in March timeframe. Was it March? In Antwerp. So we attend that one every year. And I'd kind of like to wrap up on that global level again, is that what we're doing and what we can affect and how we can change the way that the world uses refrigeration and low temp applications today is this is a global impact. This is not just, as Americans, we tend to be a little bit uppity when it comes to thinking that we've got the solution for everything, but this is something that the globe can share in the upside and change the way that refrigeration is run today, and how we use energy in this facility that is, again, the highest energy intensity per cubic foot of any commercial load in the market. Does that make sense? Did we time out?
That is super, Colin. Sorry, I was talking away, but I was actually on mute, which may be a benefit for the audience. Thank you very much for joining us this afternoon, and thank you very much, Colin, to you for sharing a little bit more insight into what you're doing and the work that Viking Cold is doing.
Okay, very good. I'm losing you a little bit, but I'd like.
I've had some really good feedback about you already from people that were in the audience. I would obviously be remiss if I didn't mention just very quickly that Viking Cold are joining us in our solar and storage finance and investment event, which is coming up next week in Texas. So we're actually in Viking Cold's home ground of Houston. Anyone that's really interested to meet the guys from Viking Cold will be able to meet James Bell, the president and CEO of the company, who'll be speaking on the program. So the website there is financetexas.solarenergyevents.com, and everyone that's signed in today can save 15% on their ticket. And if you want to find out more about Viking Cold, then the website is on the slides, which I handed out, and that's just vikingcold.com, I believe. Is that correct, Colin?
That is correct. We'd like to thank you, Joanne, for administering this webinar today, and we'd like to thank all the attendees for making time to listen to our story.
Wonderful. Thanks, everyone, and see you guys next week in Houston.
Very good. Safe travels.
You too. Bye-bye.